We're told that in an oscillating LC circuit, L is equal to 1.38 mH and C is equal to 3.47 UF. The maximum charge on the capacitor is 2.89 UC. Find the maximum current. Before we start this problem, should write out all of the variables that we have so we can see how to go about this problem. We have an L, and we have C is equal to 3.47 microfarads, and we have a maximum charge which we can denote as Q. We could say that's max charge, and that is just going to be 2.89 microcoulombs. Once we have all of this written out, we need to find our I max value, and we can do this by using two equations and combining them. We can say that our I max is equal to Q, which is the maximum charge, times omega. We don't have omega, so we also need to use omega is equal to 1 divided by the square root of LC. After we do this, we can put this into our omega right here and rewrite our equation, and we can see that our I max is now going to equal Q over the square root of LC. We have all of these values right here, so now all we have to do is plug them in. We have at the bottom denominator a square root. Inside of our square root we have L, which is 1.38. We have to make this hertz, so we're going to multiply this by 10 to the negative 3, and we have to multiply this by C, which we were given as 3.47 microfarads, and to convert microfarads to farads we have to multiply this by 10 to the negative 6, and that's going to give us farads. Once we have our denominator written out, we can write up our max charge, which is Q on the top. This is going to be 2.89 microcoulombs, and since it's micro, we have to multiply this by 10 to the negative 6 to get coulombs like this. After we plug this into our calculator, we are going to get 0.04176, and we can round this, leave it like this. And looking at our units, we have a coulomb over hertz times farad, and this is just going to be amps. And we can make sure of this because our I, which is the value we're trying to find, our current I, is always going to be in amps. So that is the answer for number 2. Another way to do this would be to use this formula right here. And if we are finding I max, we would use this graph right here, and we would set our sign to be just 1. Basically, this would give us I is equal to I max, which is similar to what we had up here. I is equal to, we could say I is equal to QW, and then plug this in IM for our I, and I max is equal to that. And our sign is 1 because we need to find the maximum current, and our max of sign, as we can see by the graph, is just 1. That's why we're just left with this part, and we put it right here. And for this, we would say our I is equal to QW, and our W, which is omega, is equal to 1 over LC, square root of LC, and we plug this in here, and we could solve it like that. Another formula that we could use, instead of this right here, would be this. Replacing our I naught with I max, and that is practically the same formula. The only difference is that we have a cosine and there's no negative out front.